So we have already seen a few chapters from your pharmaceutical engineering. Particularly, we have completed our size reduction, size separation. Then we have seen drying. We have seen evaporation. We have also seen distillation. We have also seen crystallization. Then we have completed material construction. We have also seen establishment of industry. If anybody has not attended those lectures, they can go in the application, they can watch recorded lectures. Mixing again, three chapters which are remaining from pharmaceutical engineering. One of them is a mixing. So mixing, then your humidification, dehumidification is one more, and lastly corrosion chapter. So you can see three chapters are remaining. So corrosion and humidification, dehumidification, we'll see in a one session only. So you can expect only one more session from pharmaceutical engineering. So this mixing will take in a two session. Today also I will try to finish half of it. Tomorrow half. Okay. So mixing will be completed up to tomorrow. And then on Monday you will have a test on this pharmaceutical engineering. Mixing we'll see today. Mixing. Now mixing means what? Very important. What do you mean by mixing? Mixing means to put together. Suppose you have two components. आपके पास में दो कंपोनेंट है, एक इसमें है, एक इसमें है. So what do you mean by mixing? Mixing मतलब क्या? These two components you have to put together. You have to put together these two components. Uniform mixture to form a uniform mixture. So uniform mixture, or you can say these two individual particles of these two material, they will become they will come as closer as each other and uniformly. It is nothing but the mixing. Mixing means it is nothing but the two put together. Two put together. Okay. Now we'll see. So you have two type of particles. Okay, you can say, or you can say you have two kind of material. You have two kind of material. So these blue particles and red particles. Now, if they are present in a mixture, they are present in a mixture, and if there is intimate contact between these two components, or two different particles of two components, you can see over here. So here is intimate contact with blue and red, so that is known as an ideal mixture or ideal mixing. Ideal mixture or ideal mixing. There is a, and for a mixing there should be interaction between A and B. There should be momentum कि एक पार्टिकल दूसरे पार्टिकल की जगह लेना चाहिए, तभी जाके मोमेंटम होगा, तभी जाके इंटरेक्शन होगा. So if there is a very strong interaction, so that is known as a negative deviation. If there is a weak interaction, known as a positive deviation. Just understand over here what is meant by mixing. Mixing is nothing but the two put together as close as you can. Okay, which is inseparable. Okay, so there are two terms. First one is a mixing, and second one is blending. So these two terms, they are often commonly used for each other, but they are little bit different. So दो टर्म होता है, एक तो मिक्सिंग होता है, एक तो होता है ब्लेंडिंग. मिक्सिंग मतलब क्या है? टू पुट टुगेदर. Mixture can be separated. It can be, mixing is the process of two components to put together, which can be separated depending upon the different forces acting on that. So mixture normally separate हो सकता है mixing. Now blending means what? Blending means again same thing, to put together in a such a way that, so it is a practically inseparable. So blending is a intimate mixing. Blending is a uniform and close mixing. Okay. So but these two terms, they are randomly used in the pharmaceuticals. Okay, but blending is little bit different. Blending is a more uniform mixing and inseparable, non-separable mixture. So we'll see what is mixing in detail. So there are two type of, so if you have two components, there are two type of powders. So cohesive solid, there are two type of solids. So now mixing may be either solid mixing, or mixing may be either solid mixing, solid mixing. It may be either solid liquid mixing, or it may be either liquid mixing. It may be either liquid mix. There are three type of solid mixing, solid liquid mixing. Solid liquid mixing is nothing but solubilization or emulsification or you can say suspension formation. But mostly is solid mixing and liquid mixing. These two mixings they are encountered in the pharmaceuticals. We are going to study this solid and solid and liquid mixing today. Okay. So I will try to finish solid mixing today at least. First one is the solid mixing. There are two type of solid. First solid is known as a cohesive solid and second solid is known as a non-cohesive solid. Cohesive solid कशाला म्हणायचं? Cohesive solid किसको बोलने का? When the particles of material or when the particles of solid, if they are having strong attractive forces in that, so it is not easy to mix a cohesive solid. Okay, so mixing is not easy in case of cohesive solid. Okay, so for example wet clay, अगर आपने मिट्टी ले ली उसमें पानी डाला वो बन जाएगा cohesive solid. So wet clay resistant to the flow through opening of mixer. जो मिक्सर का मिक्सर है तो उसमें फ्लो नहीं होगा प्रॉपरली. इफ देर इज नो फ्लो ऑफ दैट वेट क्ले देन हाउ यू कैन मिक्स इट विथ अनदर कंपोनेंट. आपको मिक्स करना है, कैसे मिक्स होगा? नहीं होगा ना, लम्स बनेंगे उसके. Cohesive solid means those solid which is having high interparticular interaction. Wet clay is the example. Now dry wet clay is the example. Cohesive solid. Non cohesive solid होता है दो दूसरे टाइप का. So for example grains, dry sand, plastic chips. Okay. Suppose you have grains of wheat or grains of jawar or grains of bajri, okay, or dry sand or plastic chips. So they can easily flow in the mixer. They can easily flow in the mixing utensil or mixing element, okay, because they are a non-cohesive solid. There are two types of solids: cohesive solid, non-cohesive solid. Now, what are the applications of this mixing in the pharmaceuticals? Why we are studying this mixing chapter? So, applications of mixing in the pharmaceutical in a very short. So, you know that if you want to make a tablet, so you have to, okay, if you want to make a tablet, so in the tablet you have different components, like you have your API drug, okay, active pharmaceutical ingredient, and you have diluents like your diluent is there, like a bulking agent is there, then glycinate is there, then disintegrant is there, binder is there, okay, anti-adherent, then your sweetener is there. तो these are the diluents plus drug. टैबलेट में diluent plus drug होता है जिसका आप बाद में ग्रेनुलेशन करके कंप्रेस करते हो. Now suppose that if you want to make a tablet of paracetamol 500 milligram, dose is a 500 milligram. If you want to make a tablet of E18 sulfate which is having dose of 5 milligram, so while mixing it, okay, it is easy to mix 500 milligram paracetamol with the additives, but it is not easy to mix 2 mg of that or 5 mg of that E18. So mixing is important because if there is no proper mixing, you cannot ensure the content uniformity as per the pharmacopoeia. If you want to ensure the content uniformity, there should be a proper mixing, right? So mixing is not a problem when the dose of drug is high. When the dose of drug is less, it is not, mixing is not a problem in case of if dose of drug is high, or if the API component in the tablet is having higher amount. Definitely it is a problem when drug is a potent, for example less dose. So you have to be ensure proper mixing to ensure the content uniformity. For example, mixing is very important operation in the pharmaceuticals. For example, it may encounter in the weight, that is one of the mixing is one of the unit operation in the tableting. Weight mixing. Yeah, weight mixing is important in the granulation. वेट मिक्सिंग ग्रेनुलेशन करने के पहले आप क्या करते हो, जैसे आपका एपीआई है, रिक्वायर्ड क्वांटिटी ऑफ एपीआई, बाद में लैक्टोज, बाद में जो भी है आपका एंटी एडरेंट स्टार्च वगैरह सब कुछ बाइंडर वगैरह यूज करके आप क्या है ऐसे ही नहीं लेते, आप उसको मिक्स करते हो. सो यू हैव टू मिक्स एंड आफ्टर दैट you are doing weight mixing. After that you are doing granulation and then lastly tablet. So weight mixing is very important in case of tablet and capsule, okay, tablet and capsule production. Then dry mixing is important for direct compression of tablet. Direct compression of tablet for that is dry mixing. Where dry blending is again a parallel term to the mixing. But in case of blending में मतलब क्या होता है? Blend नहीं समझ लो. Blend means it is a proper mixture which is not easily separable. But mixture it is easily separable. If you apply external force, you can easily separate the mixture. You cannot easily separate the blend. Blend is a uniform mixing. It is an intimate mixing. Intimate, है ना? It is intimate mixing. So blending is another mixing process in the powder dosage form. For example, unit powder dosage form in case of capsule also, in case of dry syrup, in case of compound powders, in case of production of pellets for the capsule. Again, mixing is very important step. Okay. Now we'll see the comparison between liquid mixing and solid mixing. Liquid mixing, liquid mixing, solid. The liquid mixing आणि solid mixing मध्ये काय difference आहे? So liquid mixing मध्ये काय? So liquid mixing is affected or affected by or it is carried out by flow current. Liquid mixing कशामुळे होते? Flow current responsible for the shifting of unmixed material or unmixed portion of liquid to the mixing zone adjacent to the impeller. मतलब liquid mixing मध्ये काय होतं? Flow current is responsible for the mixing of unmixed part of that liquid to the unmixed part of liquid near to the that impeller or that is the impeller mixing stirring element होता है उसमें. In case of solid, such flow current is not possible. There is no flow current in solid. Okay? There is a momentum. There is a momentum of particle. In case of solid, there is a momentum of particle. Momentum or movement. Now, true or homogeneous mixture can be observed in case of liquid mixing. Liquid mixing मध्ये true homogeneous mixture तुम्हाला भेटेल. But it is not okay, it is not in a case of solid. So, two or more easily identifiable phases are there in a final mix. If you do solid mixing, even in case of blending मध्ये पण तुम्हाला you can easily identify two phases. So there is a one phase having more particle size, less particle size, another phase. You can easily observe that. Okay? So in case of liquid mixing, small sample is sufficient to study the degree of mixing. So in case of solid here, large sample is required. And in case of liquid mixing, required low power for mixing. And in case of solid mixing requires high power. This is the basic difference you have to understand. So here you understand what is mixing and what is blending. इथं तुम्हाला काय कळलं मिक्सिंग काय असतं ब्लेंडिंग काय असतं या ठेवा लक्ष ठेवा ब्लेंडिंग मीन्स intimate mixing and you have applications of mixing is the one of the unit process in the various making of different dosage form. Okay. Blending is a parallel term to the mixture. Blending is a parallel term to the mixing, but in case of blending there is a more uniform mixing or you can say so intimate mixing is known as a blending. Now it is easy to separate a simple mixture. अगर solid का mixture है तो separate होगा. Intimate mixing है तो separate नहीं होगा जल्दी. तो blend is not easy to. Now cohesive solids example याद रखो. Non cohesive solid के example. So next is mixing of solid, which is defined as the process that tends to randomization of particles. Randomization of dissimilar particle within a system. Randomization of dissimilar particle within a system. As I told you, mixing means to put in together, in an inseparable manner. That is known as a mixing. Uniform mixing is related with the uniform content uniform. If you want to ensure the content uniformity of tablet capsule, you should do uniform mixing. Uniform mixing, well mixing, intimate mixing is important in case of tablet dosage form, capsule dosage form. If drug is having, okay, it doesn't matter. कंटेंट यूनिफॉर्मिटी इफ यू वांट टू इंश्योर द कंटेंट यूनिफॉर्मिटी हर एक टैबलेट में आपका 200 मिलीग्राम ही सेलोकॉक्सिप होना चाहिए. कैसे ये यूनिफॉर्म कैसे इंश्योर कर सकते हैं बाय डूइंग यूनिफॉर्म मिक्सिंग. यूनिफॉर्म मिक्सिंग इज रिलेटेड विद द कंटेंट यूनिफॉर्मिटी इन द टैबलेट. There are two type of material, cohesive and non-cohesive material. as I told you, cohesive material and non-cohesive. I have told you. So it is difficult to mix a cohesive material because of the formation of lumps and aggregates. कोहेसिव्ह मटेरियल असेल तर काय होईल लम्प्स किंवा ॲग्रिगेट किंवा लम्प्स किंवा ॲग्रिगेट बनते. In okay, what are the reasons for separation of particle? If you have two mixtures, आपके पास तुमच्याकडे दोन मिक्सचर आहेत, एक पावडर आहे आणि एक पावडर आहे, तुम्ही दोन्ही मिक्स केलं, काही वेळाने काय झालं, सेपरेट झालं. मिक्स केलं पण काही वेळाने सेपरेट होतं. सेपरेशन ऑफ मिक्सचर इज नोन एज सेग्रिगेशन. Separation of mixture is a segregation. What is meant by separation of mixture? There is a segregation. Interparticle interaction or segregation depends on the, now segregation depends on the different factors. Okay? Why segregation occurs in the mixture? की तुम्ही मिक्स केलेलं आहे पण ते सेपरेट झालं, सेपरेट का होते? What are the reason for segregation? Reason behind segregation of powder is nothing but the poor flow of poor flow of powder bed, PADE, poor flow of powder bed inside the blender. आपका जो ब्लेंडर है, मिक्सर है, उसमें आप दो डाल दिया है ना, डाल दिया आपने मिक्स करने के लिए, मिक्सिंग एलिमेंट चालू किया, ब्लेंडर चालू किया पर्टिकुलर टाइम के लिए 25 to 30 minutes. दैट इज आइडियल टाइम फॉर मिक्सिंग. हाफ एन आवर इज आइडियल टाइम फॉर मिक्सिंग. उस टाइम तक आपने मिक्स किया और छोड़ दिया, बाद में देखा है कि आपको सेपरेट हो चुका है. There is a segregation of powder. Why there is segregation of powder? What are the different factors? One of the factors is a poor flow of powder bed inside the blender. Poor flow of not a particle. Powder blade. दोनों एक powder अलग है, एक powder अलग है. So that's why powder bed. So poor flow of powder bed inside the blender. One of the reason. Then wide difference in the particle size of mixture. ना दोन component आहे तुमच्याकडे. है ना, याची particle size आहे 5 micron, याची particle size आहे 30 micron. There is a difference in the particle size of two this. So more will the difference, more will be the segregation. That difference is also important. Suppose if two particles are having similar particle size, two material are having similar particle size, so they can be easily mixed. So wide difference in the particle size of dry mixture, there is another one of the reason for segregation. Then third reason, difference in the particle density and particle shape, particle surface area, particle size distribution, density, etc. etc. There are a lot of reasons. Okay, so mostly segregation occurs by three reasons: poor flow properties of the powder bed inside the blender, wide difference in the particle size of mixture, difference in the density and shape. So if you want to understand this behavior, you have to understand what are the different forces that acts while you are mixing two material. दो मटेरियल आपने मिक्स किए, उसमें क्या क्या मॉलिक्यूलर लेवल के ऊपर चेंजेस होता है. व्हाट आर द डिफरेंट फोर्सेस दैट एक्ट ऑन अ मॉलिक्यूल? देयर आर डिफरेंट फोर्सेस. लाइक फर्स्ट वन इज inertial force. So inertial force is responsible for the holding of neighboring particle in a fixed relative proportion. So inertial forces कौन से होते हैं? van der Waals force होता है, van der Waals force is there, electrostatic force is there, surface forces. These three forces they comes under inertial forces. What is the role of these van der Waals forces, electrostatic forces or surface forces? To hold the neighboring particles, neighboring molecules in a fixed relative proportion. There is inertial force. So surface force or interface force, what is the role of that? So attractive force or cohesive force, that is known as attractive force or cohesive force. It prevents the intimate mixing. It prevents the intimate mixing. Attractive force or surface force between the particles. एक ही मटेरियल के अंदर के पार्टिकल जिसमें अगर कोहेसिव फोर्स ज्यादा है, अट्रैक्टिव फोर्स ज्यादा है, तो दैट प्रिवेंट द इंटीमेट मिक्सिंग एंड कंप्लीट मिक्सिंग बिकॉज ऑफ द सरफेस इंटरेक्शन. फ्रिक्शनल फोर्स also, frictional force decreases the momentum of particle and that tends to form a lumps. These forces depends on the surface area of the particle, surface roughness of the particle, surface polarity of the particle, surface charge of the particle, adsorb the substance like for example moisture. Moisture absorb है तो उसका cohesive force ज़्यादा रहेगा. During the mixing, particle develop a charge due to random motion, and because of it, random mixing is impossible. So if particle develop a charge during a blending, so random mixing is impossible. For effective mixing, surface to surface interaction should be minimum. Surface to surface interaction जितना minimum होगा उतना ज़्यादा मिक्सिंग इफेक्टिव होगा. Now this minimum surface to surface interaction is achieved by surface treatment. Okay, achieved by surface treatment. Are you getting or not? समझ रहा है आपको? चल क्या रहा है? Now second, now segregation. We are discussing the different forces at a while you are mixing different forces which act on a particular level, molecular level. So first, we have seen the inertial forces. We have seen the this surface or interface force. Next one is nothing but again segregation means separation occurs because of the poor flow properties of the powder inside the blender due to wide difference in the particle size of dry mixture, difference in the mobilities of individual ingredient, difference in the particle density shape during the ट्रांसपोर्टेशन मतलब क्या, एक मिक्सचर है आपका, आपने क्या किया, मिक्सचर होने के बाद में उसको रख दिया, लेकिन आप उसको दूसरी जगह पे लेके गए तो क्या होगा, ड्यूरिंग हैंडलिंग व्हाट हैपन, शेकिंग इज देयर, ड्रॉपिंग इज देयर, एट दैट आल्सो कॉजेस द सेपरेशन ऑफ डस्टिंग फाइन पार्टिकल्स, they used to go in the dust, they used to go in the environment in the form of dust, that also causes the separation. Third force is nothing but the gravitational force. Now this force increases the movement of two additional particles or group of particles. It increases the movement of two different particles or group of particles, means gravitational force is helpful for your mixing. Tumbling action also increases the particulate movement. Tumbling action also increases the movement, particular movement due to gravitational force. टम्बलिंग एक्शन मतलब क्या है, ग्रेविटेशन मतलब सीधा ड्रॉप होना, टम्बलिंग एक्शन मतलब हिल डुल के, है ना, रैंडम 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 एक्शन होता है. ओके, then particle movement takes place because of the direct contact with the mixture surface के कारण. तो particle movement मतलब one particle from one place to another place, that is a movement. So particle movement takes place because of the direct contact with the mixer surface or from contact with the one another. दो पार्टिकल एक दोनों के साथ में कांटेक्ट हो गए, या फिर उसका जो पार्टिकल का जो मूवमेंट होता है, मतलब एक पर्टिकुलर 10 पार्टिकल है ए कंपोनेंट के, पर्टिकुलर 10 कंपोनेंट है बी कंपोनेंट के, तो जब पार्टिकल का मूवमेंट होगा, एक पार्टिकल दूसरे पार्टिकल के नियर जाके बैठेगा, तभी तो मिक्स होगा ना, right? So that movement, okay, that movement, particle movement takes place because of the indirect contact with the mixer surface or from the contact with the one another. This process accelerate the movement of transitional and rotational mode of single particle or group of particle. So this is the different forces which act on a mixture while you are doing mixing. There are different type of mixing. So convective mixing is there, shear mixing is there, diffusive mixing is there. Okay, we'll see it in these three process in upcoming slide. But these two terms are important. You have to remember mixing index and what is mixing index? Standard deviation of random blend divided by standard deviation of sample blend. Random blend divided by sample blend, and it is given by Lassie's equation. ये आपको याद रखना है. There is no other option. Remember, Lassie's expression is related with the mixing. Mixing में ज़्यादा कुछ theory है नहीं, but ये equation याद नाम ही याद रखो. Lassie's equation is related with the mixing. It is related with the mixing. बस इतना याद रखो. तो आपको क्वेश्चन आता है कि match the following type of equation with their respective unit operations. When particle collision occur, exchange or transfer of momentum is achieved. When particle collision will occur, so at the time only transfer of momentum is achieved. Now, efficiency of momentum transfer depends on different. First, elasticity of collision. जो collision हो रहा है उसमें उसका कितना elastic collision है या plastic collision. So in the elastic collision, moment of transfer does not takes place. अगर collision elastic है, तो moment of transfer does not take place. So transfer of two particle will not take place, and there should be minimal loss due to electricity. And second आता है coefficient of friction. Particle having high coefficient of friction exchanges rotational momentum rapidly. जिसमें ज़्यादा coefficient of friction अगर रहेगा पार्टिकल में, तो वो ज़्यादा rotational momentum exchange करेगा. Then surface area of contact. Larger the surface area of contact, larger the exchange of moment. Then surface roughness. Surface roughness. So efficiency of momentum ट्रांसफर ट्रांसफर मोमेंटम तो पार्टिकल एक जगह से दूसरे पार्टिकल की जगह पे कितने जाएगा वो किसके ऊपर डिपेंड करता है कोलिजन के ऊपर सो फर्स्ट इलास्टिक कोलिजन दैट विल डिक्रीज दैट विल दैट विल डिक्रीज द मिक्सिंग इलास्टिक कोलिजन कोएफिशिएंट ऑफ फ्रिक्शन पार्टिकल हैविंग high coefficient of friction they will enhance the mixing surface area of the contact larger surface area larger will the exchange momentum surface roughness of the particle अगर surface roughness ज़्यादा है particle को so it is involved in the collision and decide the distribution of transferred momentum between transitional and rotational mode in centrifugal force आता है so on the rotating way centrifugal force on rotating so it helps to break aggregates in a smaller unit and helps in the mixing centrifugal force helps in the mixing what are the different steps in the mixing सबसे पहले क्या होता है कि आपके पास पाउडर है एक पाउडर है दूसरा एक पाउडर है से टाल्क और पैरास्टामोल को मिक्स करना है आपको तो आपने ब्लेंडर में डाल दिया तो पहले क्या होगा एक्सपेंशन ऑफ बेड ऑफ सॉलिड then after that there is application of three-dimensional shear force to the powder bed and then mixing long enough to permit the true randomization of particle what is mixing is nothing but the randomization of particle and then maintain this randomization these are the four steps of mixing okay the steps of the mixing so types of mixture very important again type of mixture there are two type of mixture one is known as a positive mixture one is known as a negative mixture so what do you mean by positive mixture they are formed from material which are gases and immiscible liquid where irreversible mixing would take place by diffusion without expenditure of energy or work in a provided time. Positive mixture means positive mixtures forms easily. Easy formation of mixture is there in case of positive mixture. So if two components are there easily mixing, they are known as a positive mixture. They are formed from material which are gases and immiscible liquid. Where irreversible mixing would take place. एक बार मिक्स हो गया तो उनको सेपरेट करना पॉसिबल नहीं. That is known as a positive mixture. Negative mixture example is suspension of solid in liquid. ये easily separate कर सकते हो. The required work for this formation and compound on which will separate. Timeless work is continuously suspended on them. Mixture आपको अगर सस्पेंशन अगर आपको बहुत टाइम तक रखना है you have to work on it you have to apply the force in case of suspending agent डालना पड़ेगा उसमें so negative mixture का example है suspension positive mixture का example है आपका gases and miscible liquid mixing mechanism of mixing in case of solids there are three mixing convective mixing shear mixing and then diffuse mixing or diffusion mixing what do you mean by first convective mixing so it depends on the type of mixture convective mixing can offer inversion of powder bed by means of blades paddles or by means of revolving इन यहाँ पे इतना याद रखना है कन्वेटिव मिक्सिंग मीन्स व्हाट इन्वर्जन मतलब क्या है खेती करते हो खेती में नांगर लगाते हो क्या करते हो नांगर में लगाना मतलब इन्वर्जन ऑफ बेड है ना ऊपर की मिट्टी नीचे डाल देना नीचे की मिट्टी ऊपर लाना इट इज इन्वर्जन ऑफ बेड सो इन्वर्जन ऑफ बेड मीन्स सपोज आपने एक यहाँ पे क्या किया एक पहले पैरास्टामोल का मान लीजिए पहले एक टाल्क का पूरा जो आपके पास स्टॉक था वो ब्लेंडर में डाल दिया उसके बाद में ऊपर क्या किया पैरास्टामोल का रिक्वायर्ड स्टॉक डाल दिया ये दो हो गए ना दो इन्वर्जन ऑफ बेड मीन्स व्हाट ये इसमें मिक्स हो गए ये नीचे जाएगा ये ऊपर आएगा ये नीचे दैट इज इन्वर्जन सो कन्वेक्टिव मिक्सिंग मीन्स डिपेंड्स ऑन द टाइप ऑफ मिक्सचर कन्वेक्टिव मिक्सिंग कैन ऑफर बाय inversion of powder bed by means of blades or paddles or by revolving screw ये किससे करेंगे आप एक तो मिक्सर में ब्लेड होता है देखो मिक्सर में ब्लेड होता है ब्लेड क्या करेगा शिफ्टिंग करेगा एक लेयर एक यहाँ से पाउडर वहां तक शिफ्ट करेगा जैसे शिफ्ट करेगा है ना That is known as an inversion, or that is known as convective mixing. Inversion of bed by means of blades or pedal, or by revolving screw, or by any other method, moving relatively large mass of material from one part to another part. यहाँ पे एक अंडरलाइन किया हमने, moving a relatively large mass of material from one part to another part of the powder bed from one place to another place. That is a convective mixing. So question आ चुका है एक बार कि movement of relatively large amount of particles that takes place at a time in following mixing, convective mixing. So here, what is it? Inversion of bed. Inversion of powder bed by means of blades, pedals, revolving screen, or screw by, or by another method, moving a relatively large mass. यहाँ पे देखो underline करता हूँ. Moving a relatively large mass of material from one part to another part of powder bed, from one place to another place. So ये mechanism इसमें it is a convective mixing. Question आ चुका है इसका. Depends on the type of mixture. Convective mixing can occur by inversion of powder bed by means of blades or pedals, or by means of revolving screen or screw, or by any other method. So in which there is a movement of relatively large amount of mass of material from one place to another place, from one part to another part of a powder bed. Second of the shear mixing. So in shear mixing means you have to apply the force. So as a result of force within the particular shear mixing, you have to apply the force as a result of forces within a particular mass. So there is a breakdown of attractive forces in the particle. Slip pain depending on the flow characteristic of powder. This can occupy singly or such a way to give a rise to a laminar. In when shear occurs, region shear occurs between the region different composition and parallel to their interface. It reduces the interparticular attraction. It reduces the scale of aggregation by thinning the dissimilar layer. ये थोड़ा सा critical language में बोला है. बस shear mixing में इतना याद रखो. Shear mixing means there is a breakdown of interparticular attraction by applying a shear force. That's it. Which tends to randomize your particle. Third होता है diffusion mixing. Diffusion mixing means simply there is a diffusion of particles from one place to another place. Mixing by diffusion is said to occur when random motion of particles within a powder bed causes changes in the position relative to one another. मतलब क्या है, पाउडर बेड में पार्टिकल ऑटोमेटिक मतलब यहाँ से वहां तक दूसरी जगह पे जाता है. That is known as diffusion mixing. Such exchange results in the reduction of intensity of segregation. Efficiency of tumbling mixer is highly dependent on the speed of rotation. बस इतना ही याद रखना है. मिक्सिंग मैकेनिज्म, convective mixing, इसमें large proportion inversion of powder bed occurs. Large amount of particles at a time, they will move from one place to another place in the powder bed. Shear mixing, it is a breakdown of attractive forces between the particle. Diffuse mixing occurs due to random motion. That occurs due to random motion of particle in the powder bed. बस इतना 3 टर्म याद रखो. यहाँ पे inversion of bed and large mass of material from one part to another part. यहाँ पे breakdown of attractive forces, shear mixing. लास्ट में diffusion mixing means random motion. 3 टर्म याद रखो. Degree of mixing is also called as a homogeneity. Degree of mixing is also known as homogeneity. इतना homogeneous mixer है. अगर homogeneous mixer हो तो अपन बोलेंगे यार mixing बहुत अच्छा है. So ideal mixing or perfect mixing. What do you mean by ideal mixing? Or it can be represented or it can be stated with the example of chessboard. कोई chessboard देखा होगा आपने, तो उसमें black white ऐसे squares होते हैं. एक black के बाद एक white, उसके बाद black, उसके बाद white, वैसे square होते हैं. That means you can consider black as a one component or one powder, and white as a one powder. What do you mean by ideal mixing or perfect mixing? Particles of one component are lying nearly adjacent to the particles of another component. That is nothing but the ideal mixture. So ideal mixture किसको बोलेंगे? जब आपके पास कंपोनेंट ए है, कंपोनेंट बी है, तो हर एक पार्टिकल कंपोनेंट ए का, उसके बाद बी का कंपोनेंट है, उसके बाद ए का, उसके बाद बी का, ऐसा अगर है तो उसको बोलेंगे अपन ideal mixture. So ideal mixture means what? Particles of one component are lying nearly to the adjacent to the another particle of another component. It is indicated by standard deviation. Ideal mixing is not possible. Ideal mixing is not possible होता है नहीं. Ideal mixing is not possible. And that's why if ideal mixing is not possible, then what are the criteria for mixing? Mixing किसके बेसिस पे करेंगे? Ideal तो mixing possible नहीं है. That's why acceptable mixing is there. Acceptable mixing. As ideal mixing is not possible, so acceptable mixing is done. Acceptable mixing is also having two types. In that you have random mixing and in that you have ordered mixing. Random mixing means random mixing means random distribution of particle. It means the same ratio of component in entire mixture. Same ratio of component in the entire mixture. That is random mixing. Ordered mixing क्या होता है? Describe the use of mechanical or adhesion or coating. Order मतलब particular order में रखा है. That is a ordered mixing. In that you have three. First one is a mechanical mixing of mechanical mean of ordered mixing. इसमें क्या होता है कि mass of each ingredient is divided and recombined in a number of times in a powder bed. मतलब मान लीजिए आपके पास ये वाला बड़ा और दूसरा वाला है, एक बार उसको डिवाइड करो आपको उसके दो कंपाउंड हो जाएंगे, फिर से उसको डिवाइड करो उसके चार कंपाउंड हो जाएंगे in this fashion. I will explain in that next. So ordered mixing, first one is mechanical means of ordered mixing. Mass of each ingredient is divided and recombined in number of times in powder bed. Second होता है adhesion mean of ordered mixing. Adhesion mean of ordered mixing. Adhesive forces of particle create a unit nearly identical composition depending upon the forces. Example, partial solubilization इसमें होता है या पे use of binder and granulation. Adhesion mean of ordered mixing. थर्ड होता है coating mean of ordered mixing. तो पार्टिकल इसमें एक पार्टिकल रहेगा उसके ऊपर एक ऑर्डरली मैनर में कोट करें. पार्टिकल as an assemblage may also be coated with the another ingredient to give a ordered mix, either single entity or coated particle agglomerate. ये मैं बोलता हूँ आपको इसके बाद. मिक्सिंग इंडेक्स से होता है, मैंने बोला आपको, इट इज अ स्टैंडर्ड डिवीजन ऑफ रैंडम ब्लेंड डिवाइडेड बाय स्टैंडर्ड डिवीजन ऑफ सैंपल ब्लेंड. एंड रिमेंबर मिक्सिंग इंडेक्स शुड बी लेस देन 1. इसके ऊपर भी क्वेश्चन आ चुका है. Mixing index should be less than 1. You can see over here. So adhesion mean of ordered mixing. Adhesion mean of ordered mixing. Adhesion by using solubilization, partial solubilization. तो ये पार्टिकल जो है एक कंपाउंड है, ये दूसरा कंपाउंड है. Partial solubilization के कारण these particles they will adhere on the another component of particle. So that is known as a adhesion mean of ordered mixing. ये ordered mixing. This is okay, by using partial solubilization. दूसरा होता है adhesion by using binding agent use करके अपन ये mix ordered unit of agglomerates और granules. बाद में होता है coating mean of adhesion, coating mean of ordered mixing. तो particles coating ये प्री कोटेड पार्टिकल है जो ऑलरेडी कोटेड, और दूसरा ऑर्डर्ड यूनिट सिंगल कोटेड पार्टिकल, या फिर ऐसा भी हो सकता है कि सिंगल पार्टिकल कोटिंग, ऑर्डर्ड यूनिट सिंगल कोटेड पार्टिकल. क्राइटेरिया है ना आइडियल मिक्सिंग नॉन आइडियल मिक्सिंग में क्या होता है बोलता हूँ. सो व्हाट इज मीन बाय परफेक्ट मिक्सचर? सो इट इज अ परफेक्ट मिक्सचर. ओके, सो यू कैन सी दिस इज वन कंपोनेंट, दिस इज द सेकंड कंपोनेंट. सो इट इज अ not a mixture, it is a segregation, complete segregation. ये अलग अलग है. What is meant by perfect mixture or ideal mixture? When this unit and this unit they are exactly like this. ये क्या है second वाला, ये क्या है second वाला. So if they are in a closely nearly to each other, what is a perfect mixture? It is not possible. But random mixture is this. So this is the random mixture. क्राइटेरिया फॉर मिक्सिंग इक्विपमेंट के लिए क्या क्राइटेरिया होना चाहिए? इट शुड बी फिल्ड नॉट मोर देन, शुड नॉट बी फिल्ड मोर देन 60% ऑफ कैपेसिटी. क्यों? बिकॉज जब भी आप मिक्सिंग करने जाओगे, सो व्हेनेवर विल गो फॉर मिक्सिंग देयर इज अ एक्सपेंशन ऑफ पाउडर बेड. एक्सपेंशन होगा, पाउडर पाउडर का इतना आपने रखा है उतना नहीं, वो एक्सपांड होगा. That's why you don't say, for example, if a mixer is having capacity of 100 kg, 100 kg का मिक्सिंग कैपेसिटी आपका वो मशीन का, उसमें ऐसा इसका मतलब ये नहीं कि 100 के 100 किलो डालना है, मिक्स कर सकते हैं. देयर विल बी नो प्रॉपर मिक्सिंग. सो यू हैव टू कीप a certain void, certain space in the instrument so that for effective mixing. So it should be filled not more than 60% of capacity, and you should leave sufficient mixing volume to allow the powder bed to sufficiently significant shearing force to prevent the aggregation. There should be centrifugal effect to prevent the separation of according to the weight. Then again, particles subjected to movement in dimensions sufficiently. So particles, while mixing, particles should subject to three-dimensional movement sufficiently. Mixing process should not be stopped abruptly. Suddenly आपको mixing process stop नहीं करना है, धीरे धीरे stop करो. तो suddenly stop किया तो there is a separation of mixture. Factors affecting on a mixing, कौन से factors हैं? Nature of the surface. So if surface is rough, there is a rough surface of particle. So what happens? Problem with the rough surface of particle of any component result in the entry of active substance into the space, into the space of that रफ सरफेस है आपका. एक पार्टिकल का सरफेस रफ है, दूसरा पार्टिकल का साइज कम है, क्या होगा? तो उसके बीच में ये अटक जाएगा. प्रॉब्लम विद द रफ सरफेस ऑफ पार्टिकल ऑफ एनी कंपोनेंट, if there is a rough surface in any one of the component, what will happen? Another component will get entry, or active substance will get entry into that component, okay, and it will occupy that space. So in this case, what you have to do, you have to add third substance. Use third substance that can decrease the aggregation. Okay, so for example, aerosol and zinc oxide. If zinc oxide लेते हैं तो उसका सरफेस जो होता है ना वो बहुत ही रफ होता है. जब एरोसिल यूज करते हो, दैट इज कोलाइडल सिलिकॉन डाइऑक्साइड. एरोसिल क्या होता है? एरोसिल इज नथिंग बट द कोलाइडल सिलिकॉन डाइऑक्साइड. So when it is added, so it will occupy the rough surface of zinc oxide, and then now zinc oxide is now ready. It can be mixed with the another component. Okay? That nature of surface. The density of particle, अगर बहुत ज़्यादा density difference है, density of small particle, that is one component, is if the density of one component is higher, and if you are mixing, if you are stopping mixing suddenly due to difference in the density, what will happen? So that result in the separation or demixing. So दोनों का डेंसिटी ना ज़्यादा डिफरेंस ना हो चाहिए. एक का डेंसिटी बहुत ज़्यादा है, एक का बहुत कम है, तो वो अपने कितनी बार मिक्स किया तो वो सेपरेट होने वाला है. पार्टिकल साइज also affect the mixing. Two components having similar particle size, they are easily mixed. If there is a difference between particle size of two components, that leads to separation due to upward movement small particle in the species. Ideally 100 micrometer, ideally 100 माइक्रोन का एवरेज पार्टिकल साइज अगर है, दैट इज अ गुड फॉर मिक्सिंग. पार्टिकल शेप, इरेगुलर शेप अगर है पार्टिकल, दैट बिकम इंटरलॉक्ड एंड inseparable. Ideally particle should have spherical shape. Particle charge also affect the mixing, that leads to attractive forces due to electrostatic charge on the particle. Proportion of material, कि ऐसा नहीं कि आप दो कंपोनेंट मिक्स कर रहे हो लेकिन एक कंपोनेंट लिया आपने 70-90% कंपोनेंट लिया, so there should not be huge difference. If there is a large difference in the proportion of mixing is done in a ascending order. और ज़्यादा डिफरेंस है तो ascending order. मतलब क्या है ना, मान लीजिए आपको एक आपके पास एक 100 मिलीग्राम है, तो आपके पास मान लीजिए 1 ग्राम है, मतलब 1000 मिलीग्राम एक टाल्क है ना, और आपके पास में क्या है 10 मिलीग्राम क्या है ड्रग है. डायरेक्ट मिक्स नहीं करना है. मिक्स कैसे करना है? इसमें का 10 ले लो और ये पूरा 10 ले लो, मिक्स करो प्रॉपर्ली. बाद में उसमें ये कितना बन रहा है 20, और इसमें का फिर 20 ले लो, ये 20, प्रॉपर मिक्सिंग हो जाए. अगर अभी कितना यूटिलाइज होगा 20-30, ये कितना होगा यहाँ पे 30 and 40y. So इसमें का और 40 ले लो. So likewise that is known as a proportional mixing or geometric mixing. Evaluation of mixing को evaluate करेंगे, कैसे करेंगे? So statistical parameter you have to apply. So you have to check arithmetic mean of particle size or particle size distribution attributed to a constant attributed to a concentration of component of particle size of their particular component. In standard deviation आपको check करना होगा. That is a spread of the spread dispersion usually sample applicable for a specific material, specific mixer. It should be within plus minus 3 standard deviation. Then relative standard deviation. You have to. It is also another quality check for mixing. Statistical parameter. Arithmetic mean standard deviation. RSD relative standard deviation. उसका फॉर्मूला था ये standard deviation divided by mean into 100. Mixing index से होता है standard deviation of random blend divided by standard deviation of sample plane. It should be less than 1. Sampling mixing इवेल्यूशन करने के लिए सैंपल लेना पड़ेगा ना आपको मिक्सचर में से. सो सैंपल कब लेना है आपको? आफ्टर completion of mixing, after completion of blending, you have to obtain a sample. Sample can be obtained by two methods. Scoop method is there. There is scoop sample and thief sampling there. thief sampling के लिए thief probe होता है, वो आपको मैं बाद में दिखा दूंगा. Now mixtures, they are mixing elements, different mixers for mixing. तो लिक्विड मिक्सर्स अलग रहेंगे, सेमी सॉलिड मिक्सर्स अलग रहेंगे, and solid mixers. Solid mixers are different. They are classified into either batch type or continuous type. So in the batch type, remember classification के ऊपर क्वेश्चन आता है. Batch type of mixers, your tumblers, tumbling mixers, tumbling mechanism. So in this twin cell or double cone blender, cube blender, tetrahedral blender. एजिटेटर मिक्सर्स, इसमें रिबन मिक्सर आता है, प्लेनेटरी मिक्सर आता है, नाउटा मिक्सर आता है, फ्लूइडाइज्ड एयर मिक्सर आता है. प्रोसेसर्स में ये छोड़ो, प्रोसेसर्स में आएगा लॉजिन, डाइसोना मिक्सर, ग्राल मिक्सर. कंटिन्यूस टाइप ऑफ मिक्सर में आएगा ब्लेंड, एसिक, बैरल एंड जिगजैग. सब में देखेंगे अपने जिगजैग मिक्सर वाला देखेंगे, रिबन मिक्सर देखने वाले, प्लेनेटरी मिक्सर देखने वाले. इन केस ऑफ लिक्विड मिक्सिंग, batch type of liquid mixer is impellers, propellers, turbines and pedal. Impeller, turbines and pedal, they are the impeller. Jet mixer में air jet and fluid jet. Continuous mixer में आता है baffled pipe mixing chamber. Semi solid में batch type और continuous type. Continuous type में मिल आएगा roller mill and colloidal mill. And batch type में sigma blend and planetary. Classification of mixing equipment. So nature of mixer, example and mixing mechanism. So first is the batch type of small scale mixer. Batch type 1 batch 2 batch continuous नहीं. Okay. On a small scale mortar and pestle is the example. Mechanism क्या होता है? Trituration करते हैं. And next होता है tumbling mixers or they are also known as cylindrical mixers. Now without mixing blade. Tumbling mixers और cylindrical mixer without mixing blade. इसका एग्जांपल होता है डबल कोन ब्लेंडर, वी कोन ब्लेंडर विदाउट बेपल्स और मिक्सिंग ब्लेड. एक्शन के मैकेनिज्म टम्बलिंग एक्शन, टम्बलिंग मिक्सर विथ मिक्सिंग ब्लेड, इसमें अभी मिक्सिंग ब्लेड इंक्लूड होगा. वी कोन ब्लेंडर एग्जांपल तो वही रहेगी, वी कोन ब्लेंडर विद द मिक्सिंग ब्लेड, डबल कोन ब्लेंडर विद द मिक्सिंग ब्लेड. इसमें और एक मैकेनिज्म ऐड होगा, टम्बलिंग प्लस शेयरिंग. स्टैटिक मिक्सर एग्जांपल है रिबन मिक्सर, रिबन ब्लेंडर, सिग्मा ब्लेंडर, प्लांटरी. Stationary cell and rotating blade is the mechanism. Air mixers, fluidized mixer. Example, fluidized mixer, air supported blending. Then continuous type of large scale mixer, continuous type or large scale. So parallel type of mixer is there and zigzag type of mixer. इसके ऊपर GPAT में क्वेश्चन आ चुका है. Zigzag type of mixer. इसमें मैकेनिज्म क्या है? रोटेटिंग सेल विद रोटेटिंग. इसमें एक आधा क्वेश्चन आ सकता है आपको पूरे चैप्टर में, मिक्सिंग ऑफ सॉलिड लिक्विड. इसमें मिक्सिंग ऑफ सॉलिड एंड सॉलिड, मिक्सिंग ऑफ लिक्विड मैक्सिमम एक आधा क्वेश्चन आ सकता है. जैसे अभी तक ये यहाँ प्रीवियस स्लाइड में भी नहीं बोला था वहाँ पे याद रखना है कि बैच टाइप फॉर स्मॉल स्केल कौन सा है, मॉडल एंड पेस्टल ट्राइचुएशन की मैकेनिज्म, टम्बलर मिक्सर्स और सिलिंड्रिकल मिक्सर्स विदाउट मिक्सिंग ब्लेड, डबल कोन ब्लेंडर, वी कोन ब्लेंडर, क्यूब ब्लेंडर मैकेनिज्म रहेगा टम्बलिंग एक्शन. These same thing with the mixing blade, टम्बलर मिक्सर विद द मिक्सिंग ब्लेड, यही एग्जांपल है उसका. उसमें ब्लेड रहेगा तो उसमें एक एडिशनल मैकेनिज्म ऐड होगा शेयरिंग. स्टैटिक मिक्सर में आएगा रिबन ब्लेंडर, सिग्मा ब्लेंडर, प्लांटरी पैडल. फ्लूइडाइज्ड एयर मिक्सर में फ्लूइडाइज्ड एयर मिक्सर, एयर सपोर्टेड ब्लेंडिंग होता है इसमें, ये क्या है. बाकी कंटिन्यूस में जिगजैग मिक्सर एंड बैरल टाइप ऑफ मिक्सर.